Solution of question number 1. Here we have T be a linear transformation from R4 to R4, and we have its minimal polynomial as x square plus x plus 1, and we have to tell about the nature of eigenvalues of T, that is T has real eigenvalues or imaginary eigenvalues, like that. Okay, now we know if lambda be eigenvalue of T, then lambda must be a root of its minimal polynomial. In fact, we have its if and only if statement, that is lambda be eigenvalue of T if and only if lambda be a root of its minimal polynomial. Now here the minimal polynomial is x square plus x plus 1, so it has only imaginary roots, that is 2 roots, and that are those are imaginary. So this will implies T has only imaginary eigenvalues, and that is both the eigenvalues of T are imaginary. So T has no real eigenvalues, so our D option is correct. Solution of question number 2. Here we have V be a finite dimensional vector space and T be a linear transformation on V, and also we have rank of T square equal to rank of T, that is dimension of range space of T square is equal to dimension of range space of T. Now we have to tell about range space of T and null space of T, that is R of T and N of T. Okay, now we know dimension of V, that is dimension of domain space, is equal to rank of T plus nullity of T. Here T be a linear transformation from V to V, so our domain space is V. And here T square also be a linear transformation from V to V. So again we have dimension of V is equal to rank of T square plus nullity of T square. Since we have rank of T equal to rank of T square, so that will implies nullity of T should be equal to nullity of T square by the given relations. Okay, so since here nullity of T and T square both are same, so we have dimension of null space of T is equal to dimension of null space of T square. Now firstly we will find the relation between null space of T and null space of T square. So now let alpha belongs to null space of T, so that is T of alpha equal to 0. Now operate T on this, so we have T of alpha equal to T of 0. Since T be a linear transformation, so T of 0 same as 0, that is we have T square alpha equal to 0. So this will implies alpha belongs to null space of T square, but our alpha belongs to null space of T. So here we have null space of T is a subset of null space of T square, but we know null space of T and null space of T square both are the subspaces of vector space V, and here null space of T is contained in null space of T square, so that will implies null space of T be the subspace of null space of T square, and both having same dimension, so that will imply null space of T is equal to null space of T square, because we know if W be the subspace of vector space V, then dimension of W is equal to dimension of V if and only if V equal to W. Okay, now it is clear that null space of T square is also contained in null space of T. So if alpha belongs to T square, that is T square alpha equal to 0, then alpha must belongs to null space of T, that is we also have T of alpha equal to 0. Okay, so now let alpha not equal to 0 and alpha belongs to null space of T intersection range space of T. So that will implies alpha belongs to null space of T and alpha belongs to range space of T. So alpha belongs to null space of T, that will implies T of alpha equal to 0, and alpha belongs to range space of T, then there must exist an element in codomain V such that T of in fact let beta be the such element, then we have T of beta equal to alpha. Now operate T on this, so we have T of beta equal to T of alpha, but we already have T of alpha equal to 0, so that will implies T of beta equal to 0. So here we have beta is the element in codomain such that T of beta equal to 0, but T of beta equal to alpha and alpha not equal to 0. This will contradict our assumption that T of alpha equal to 0. So that will imply that doesn't exist any alpha which is not equal to 0 containing null space of T and range space of T both. So the only possibility for alpha is equal to 0. So here we have null space of T and range space of T both have common element is only 0. That is null space of T intersection range space of T equal to 0 vector. So we have null space of T and range space of T are the distinct subspaces of vector space V. So here our option A is correct. Solution of question number 4. Here we have a series of real number whose nth term is denoted by an and defined as an equal to n upon 2 raised to n when n be a prime number and 1 upon 2 raised to n when n not a prime number. So when we notice this nth term, then we observe n occur as an exponent here. So we can apply root test here for the convergence of series. So in the root test we have to find the limit n tending to infinity an to the power 1 by n. So here when we take an to the power 1 by n, then we have n to the power 1 by n divided by 2 if n be a prime number and 1 upon 2 if n not a prime number. Now when we compute the limit of this term, then we have 1 by 2 if n be a prime number and when n not a prime number, then also limit value is 1 by 2. So the thing is limit n tending to infinity an to the power 1 by n equal to half and half is less than 1. So by the root test our series is convergent. So here our option A is correct. Solution of question number 9. Here we have series of real numbers and we have to find its sum. Here we have expanding form of the series and in this form we cannot find out its sum. So firstly we will find its nth term. So to evaluate nth term, we will observe each term of the series. So when we observe each term of the series, then we notice that denominator part of nth term will be n factorial. Now we have to find numerator part. So to evaluate numerator part, that is numerator part of nth term, we will take sum of the n numerator terms. That is we will take as is equal to 4 plus 11 plus 22 plus 37 till nth term as Tn. Now here our aim is evaluate Tn. To evaluate Tn, we will rewrite as by shifting its first term. That is as is equal to first place is 0. Then at the second place we have 4 plus 11 plus 22 till Tn minus 1 plus Tn. Now we will subtract these two terms. So on the subtraction we have left hand side is equal to 0 and right hand side is equal to 4 plus that sum as 7 plus 11 plus 15 plus 19 till Tn minus 1 and then minus of Tn. So here that middle term is the algebraic sum of the n terms of the algebraic series. So when we compute its sum, then we have n minus 1 divided by 2 times 14 plus n minus 2 times 4. So from here we can find Tn as Tn equal to 2n square plus n plus 1. So the numerator of the nth term of the series will be 2n square plus n plus 1. So we have that nth term Tn equal to 2n square plus n plus 1 divided by n factorial. This term we can write as 2n divided by n minus 1 factorial plus 1 upon n minus 1 factorial plus 1 upon n factorial. Again rewrite this term, that is rewrite the first term. So the first term we can write as 2 times n minus 1 plus 1 divided by n minus 1 factorial and same terms as it is. Then when we evaluate this term, then we have 2 divided by n minus 2 factorial plus 3 divided by n minus 1 factorial plus 1 upon n factorial, and these are the well known as exponential function. So the sum of the series is equal to 2e plus 3e plus e minus 1. So that is we have 6e minus 1. So here the sum of the series is 6 times e minus 1. So here our option B is correct.